we have reached the last lever in the production part of the course. So far, when the model was not quite right, we worked around it, better prompts, retrieved context, guardrails. But sometimes the base model itself is the problem. It does not know your specialized domain. It will not hold your exact tone. It keeps drifting from the precise format you need, no matter how carefully you prompt. At that point, you can do something more fundamental. You can change the model itself. That is fine-tuning. And the catch has always been that fully retraining a model with tens of billions of parameters costs a fortune and needs a rack of expensive hardware. Today we explain fine-tuning and then the breakthrough that made it affordable for almost anyone, a method called LoRA. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here is the whole idea in one sentence. Fine-tuning means taking an existing base model and training it further on your own set of examples so it adapts its behavior to a specific task, tone, or format. You are not building a model from scratch. That costs millions, and we will leave it to the big labs. You are taking one of their finished models and giving it a focused extra education on your data, the way a hospital might take a fully trained doctor and put them through a short specialization. Show it thousands of examples of your customer emails in your house style, and it learns to write in that style by default, without you having to spell it out in every prompt. But before we go further, the single most important question in this whole episode: when should you fine-tune at all? Because beginners reach for it far too early. Here is the honest rule of thumb, and it ties our whole course together. If your problem is the model does not know certain facts, do not fine-tune, use RAG. From episode 13, give it the facts at runtime by retrieving them. If your problem is the model does not behave the way I want, wrong tone, wrong format, wrong style, missing a skill, that is when fine-tuning earns its place. Put simply, RAG is for knowledge, fine-tuning is for behavior. And always try good prompting first. It is free and instant. Fine-tuning is the heavier tool you reach for once prompting and retrieval have hit their ceiling, because it costs data, time, and effort to maintain. Now, the cost problem and the clever fix. A modern model is a vast collection of numbers called weights. Its parameters, billions of them, as we have said since episode 1. Traditional full fine-tuning means adjusting all of them, which requires enormous memory and compute, basically the same brutal setup used to train the model in the first place. Out of reach for most people. So researchers asked a sharp question: do we really have to change all the weights to teach a new behavior? And the surprising answer was no. That insight is the foundation of LoRA, which stands for low-rank adaptation, and it belongs to a family called parameter-efficient fine-tuning. Here is how LoRA works, in plain terms. Instead of editing the model's billions of original weights, you freeze them completely. You touch none of them. Then you inject a tiny set of brand new, small weights alongside the original ones, and you train only those. Picture the giant frozen model as a finished textbook you are not allowed to write in, and LoRA as a thin stack of sticky notes you add in the margins that adjust how it is read. The number of new weights can be less than 1% of the original model, so instead of training tens of billions of parameters, you might train a few million. The result is dramatic. Fine-tuning that once needed a server farm can now run on a single decent GPU in hours instead of days, for a tiny fraction of the cost. And because you only changed a small set of weights, the trained result is a small file you can store and swap easily. You keep the one big base model and snap on a different little LoRA for each task. And there's one more multiplier worth knowing, because it connects back to episode 8. You can combine LoRA with quantization, the trick of shrinking the model's numbers to fewer bits. Load the big base model in a compressed quantized form so it barely fits in memory, then train a small LoRA on top of it. That combination has a name, QLoRA, and it is what lets enthusiasts fine-tune genuinely large models on a single consumer graphics card at home. Quantization shrinks the model to fit, LoRA makes the training cheap, and together they put customizing a serious model within reach of an individual, not just a corporation. So, how does this land depending on who you are? As an individual or hobbyist, this is the part that got fun. With QLoRA and an open model from LLMs, you can fine-tune a model on your own writing or a niche dataset on hardware you already own. Something unthinkable a few years ago. As a startup, the discipline is to resist fine-tuning until you have proven you need it. 90% of the time, good prompting plus RAG gets you there faster and cheaper. But when you truly need a consistent behavior or specialized style at scale, a low array on an open model can be both higher quality and cheaper to run than paying for a giant general model on every call. And as a large enterprise, fine-tuning is how you bake in your domain language, your tone, and your compliance-shaped behavior. But it comes with real obligations. You must version your models. Rerun the evaluations from episode 31 on every fine-tune and watch your training data carefully, because whatever bias or sensitive information goes into the data gets baked permanently into the weights. So let us bring it home. When prompting and retrieval are not enough, and the model's actual behavior needs to change, you fine-tune, training an existing base model further on your own examples, remembering the rule, RAG for knowledge, fine-tuning for behavior. And you almost never do it the expensive old way. You use LoRA, freezing the original weights and training a tiny set of new ones, often under 1% of the model, which slashes the cost and hardware. And you can stack it with quantization as QLoRA to adapt big models on a single GPU. That completes the production part of our course. You can now build, ground, agentify, remember, evaluate, guard, and adapt. From here we go under the hood one more time, into a bonus track on the advanced internals that make today's frontier models fast and powerful. We start with the architecture behind many of the biggest models you use, where the model is secretly not one network but many, and a router picks which to use for each token. That is mixture of experts, and it is exactly where we go next. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.